Hi everyone, let's do Leetcode 143 reorder list. So we're given the head of a singly linked list and we want to reorder this list following this form here. So this can be a bit confusing, so let's look at an example. So given this input list, this is the output we are looking for. So the first position of the output, we got the initial node. The second position, we've got the last node of the list. The third node is the second node of the input list. And the last node is the third node of the list. So as you can see, we alternate one node from the beginning and one node from the end. And that's how we get this output node. There are a couple of ways to do this problem. So one is to have time complexity equals to big O of n and space complexity equals to big O of n as well. This first way, what we could actually do is get the input list, put it in an array, and then what we could do is have a pointer at the beginning and a pointer at the end, and actually form the output as we traverse through the array. So we could have the output list with the first node in the array, the second node to be the last node in the array, then move the pointers and do the same. But this is going to require extra space. There is a more efficient solution, which is actually one that requires constant space. So basically it's not going to get any extra space, and the time complexity is going to be the same, big O of n. So let's actually see how to solve using this different method that's gonna just take a big O of one space. Let's take again this list as an example. So a different way to solve this problem is to actually use the following method. What we could do is we could split this list in two and then merge the elements in an alternating way. So this is the middle of the list, as we know. What we could do is start at the beginning, have the first node as the output, then go to the end of the second and get this element and have it as the next one in our output list. Then move over to the second element in the first list, add it here. But now we've got an issue actually. As you can see, this is not a doubly linked list, it's actually a singly linked list. So we can't go from 4 to 3. So that's actually a problem. So how can we solve that? One way to solve it is actually get the second half of the list and then reverse it before starting the merge. So we could do something like this. But you might be wondering, how is this algorithm going to work? So there are actually multiple steps. So let's go through each step and then let's go through an example. The first step in the algorithm is to find the middle point of the list. So how can we find the middle of the list? So one way is to have two pointers, a slow pointer and a fast pointer. Let's initialize two pointers. So fast is gonna move by 2 and slow is gonna move by 1 position. So if our fast starts here, we're gonna move it by 2, slow is gonna move by 1, so slow is going to be here, fast is now here. And as we can see, fast is already at the end of the list and slow it's at the end of our first list. So actually our middle is here, wherever slow pointer is. But you might be wondering, what if it's a odd list? So let's say we also had a 5 here. In case of a odd linked list, our method is still going to work. Fast is first going to move here, slow is gonna move here. Now we want to move fast again. Fast is now going to be null and slow is gonna be here. We have first list, which is this one, and our second list, which is this one. And when we are going to merge, it's still going to work. You'll see it in a bit when I'm gonna go through an example. We now know how to find the middle of our linked list. Okay, so we have the middle of our linked list. We now want to split the list in two. What this actually means is that we want the end of our first list to now point to null. Once we have split the list, we need to go to the next step, which is reverse the second list. It's quite simple. I've actually made a video on another Leetcode problem where we have to reverse a linked list, so please check that out. We're simply going to change the way the links work. So 5 is now going to point to 4. So once we have reversed our second list, we reach our last step, which is we merge our lists. How can we merge through the list? What's gonna happen is we're gonna start with the head of our first list, which is gonna be our output. Now we want this node .next to be equal to 5 and not equal to 2. So this link is going to break and 1 is now going to point to 5. And now we want to break this link and we want to have 5 to point at 2. We then want to move our pointers. So you might be wondering, oh, we have broken the list, how we are going to move? We actually need to store these two links before breaking them. So we will actually have some extra variables in the code that's going to be clearer. So now 2 is going to point to 4 and 4 is now going to point to 3 and 3 is pointing to null. So this is actually the desired output. As explained, this solution has a time complexity of big O of n and it doesn't use any extra memory. Okay, let's try some code now. I've added some comments with the various steps, so that should make it a bit easier. So the first thing we need to do is find the middle point of the list by using slow and fast pointer. Let's have two pointers, a slow and a fast one. So slow is going to start at the head and fast is gonna be one position after slow. So we now want to move fast until it's not at the end of the list or until fast is not null. So this is how we can do it, and we're going to use a while loop for that. We want to move slow by 1 and we want to move fast by 2 positions. So now our slow pointer is going to be at the middle of the list. What we want to do is we want to split the list into 2. The way to do is to have slow.next to point at null. The head of the second list is actually this one, slow.next. So now that we have split our list, we want to reverse the second half of the list. And in order to do this, we actually need a variable that is gonna contain the previous node, which are actually gonna initialize at none. This should be none, not null. So now we want to reverse the second half of the list, so we need a condition while second is not null. We want to actually reverse the nodes. So we're actually going to save the links in a temporary variable. So as we said, second is now the head of the second list. So we want to save the connection to the next one. We want to actually reverse the list. So second.next is now equal to previous one, which is initially pointing to null. And previous is now going to become second. And second is going to become our temp. Okay, at this point we have two lists and the second half of the list is also reversed. The last step we need to do is actually want to merge the two halves. So let's initialize our two pointers. So first pointer, which is going to be the head of the first list, and the second pointer, which is actually going to be the beginning of the second half. So this is gonna start at previous. We need a while loop now. So we know that the second list is probably going to be shorter if it's even. So we just need a condition while second is not null. We want to first store the current links of the two nodes, and you can use temporary variables. So let's have temp1 and temp2 and let's initialize them. So first.next and second.next. We want to actually have first.next to point to second. So what's happening is the node from the first list is going to point to the node from the second list, and then we want the second.next to point to temp1. So what we are actually doing is we are putting the node from the second list in between nodes of the first list, and that's how we actually achieve that. At the end we want to simply update the first and second pointer. Okay, the coding is complete. We don't need to return anything as the exercise said. Let's see if this works. Okay, there is an error. So let's see. Okay, I think the error is because of these two lines. So slow.next should become null after we have saved it into second. We can get rid of that. So let's see if this works now. As you can see, it does work. If you found this video useful, please like and subscribe, and also check the other problems I've solved. There is a playlist called Blind 75. Thank you.